Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Mohd Faisal bin Hushim. I'm from Universiti Hussein on Malaysia. So today I will present my project entitled Novel Port Fuel Injection Retrofit System for Small 4-stroke gasoline engine. As we know, motorcycles are the primary option for transportation for several countries. As can be seen in the table, around 2010 in Malaysia, there are about over 9 million registered motorcycles. And the year after, this number increases about 28%, and it's come to 11.552 million. In 2013, in Vietnam, there are about 37 million motorcycles registered in that country. So these numbers are increasing year by year. So even though the motorcycles are currently using fuel injection system, however, there are still many motorcycles on the road that still using carburetor system as its sole of fueling system. Due to the increasing fuel price and stringent emission regulation have put demands for a fueling system. Then electronic fuel injection system that has been introduced around 1980, which is it offer many advantages over the carbureted system, such as improved fuel economy and reduction in harmful emissions. The motivation to develop the port fuel injection system, which is the retrofit port fuel injection system, is it will improve the fuel economy by 6%, at least 6%, and reduce the harmful emission. For the hydrocarbon, it will reduce about 26%, and the carbon monoxide, it can be reduced around 70%. This motivation came from Cornuro, Lete and Salazar based on their studies. So for the small gasoline engine, the engine capacity is ranging between 50cc to 150cc, and the characteristics of these small engines are it is small, light, and good mobility, and of course simple operation and maintenance. So for the technological solutions, there are many technological solutions in order to improve combustion, in order to reduce the emission, harmful emission and so on. So there are about 3 technological solutions that we have considered in this study, which is changes in engine design, or what we call it as downsizing, the use of exhaust treatment, which is what we call it as catalytic converter, and then to improve combustion quality that affects the air-fuel ratio. So for this study, we just focus on how to improve the combustion quality by using the port fuel injection system. So the investigation framework from this study consists of 4 factors. First, we need to select the engine, whether 2-stroke or 4-stroke engine, and then select the best fuel injection system. As we know that fuel injection system, we have 2 types, direct injection and port fuel injection system. And then after that, we need to know the best location and angle to put the fuel injector, and then the intake manifold angle. For the engine selection, as we know, there are 2 types of engine, 2-stroke and 4-stroke. So the difference between these 2 types is the way of supply of air fuel mixture, and then the number of strokes to complete the cycle. For a 2-stroke engine, the burn gas not completely cleared from the cylinder, and then it will reduce the combustion efficiency. The shorter period in intake port is open, a relative small amount of air is admitted. Hence, with less air, less power per stroke is produced. And based on the comparison, based on Remesh 2009 and Comas 2003, okay, based on this comparison, two-stroke engine, okay, emits high carbon monoxide and consume more fuel. Okay. For the four-stroke engine, okay, the potential for this engine is very lean operation. It can operate in very lean operation. Okay, might operate unthrottled or less throttle at part load, consume low fuel but produce high thermal efficiency, have high volumetric efficiency, and emits low emission pollution. Okay, based on Asia Pacific Environmental Innovation Strategies 2011, several countries have started to restrict the use of two-stroke engine in order to improve the air quality. So for this project, we choose the four-stroke engine as our engine for test. Okay, and then the selection of fuel injection system. Okay, as I said, there are two types: gasoline direct injection (DI) or GDI, and port fuel injection system (PFI). Okay, for this project, we have choose PFI system because it promotes low capital investment rather than direct injection system, and there are several issues regarding direct injection system. Okay, this is the issues on gasoline direct injection system. First, the main issue is direct injection system is more complicated. So usually direct injection system is best for medium to heavy gasoline engine. So for this project, we focus on small gasoline engine. So we need to use not a so complicated system. Okay, and the application of direct injection system presents many specific challenges, which is the fuel injector deposit and higher number of particulates that have been emitted as compared to PFI system. Okay, another issue is the investment cost is too high as compared to port fuel injection system. Okay, so we have already choose the fuel injection system that we will use port fuel injection system. So in order to use port fuel injection system, we need to consider the intake manifold design. So for this project, okay, we use 150 degree and 90 degrees for intake manifold study. Okay, for this project, as can be seen in the picture here, there are two types of intake manifold with different angles, which is 90 degree and 150 degree. Okay, and then another important thing is we need to consider the fuel injector position. Okay, for this project, we have considered two angles, which is 48 and 68 degrees that to be investigated. Okay, so why we choose the retrofit technology? Okay, the importance of retrofit technology is it promotes minor modification, okay, less difficulty in maintenance, and of course consume less work and cost. So for the simulation work, okay, we use GT power simulation. Okay, the purpose of this simulation is to find the best engine performance based on different intake manifold angles. So there are about 6 angles that have been studied. Okay, start from 30 degrees up to 180 degrees. Okay, as can be seen in the figures. Okay. So based on this simulation, as can be seen for the breadtalk, okay, manifold A produce the highest torque, which is 11 Newton meter. Okay. Okay, for the brake power and fuel consumption consumption, okay, manifold A produce highest brake power while it consumes low fuel consumption. Okay, and then the brake mean effective pressure, okay, followed the brake torque, and manifold A produce the highest. Okay, so for the internal combustion engine, it is desirable to have high BMEP to produce high power per in cylinder pressure. Okay, based on this simulation study, okay, manifold A have produced higher engine output, okay, and then lower brake specific fuel consumption and overall engine speed. However, due to the space limitation, we have choose manifold B, okay, and then the influence of angle on engine performance and BSFC are negligibly small. Okay, so for the development PFI system, okay, there are two angles that we have used, okay, 90 degree and 150 degree, while the injector location we have choose is 48 degrees and 68 degrees. So for the experiment study, we have produced about 4 intake manifold, okay, with different injector location. Okay. For the instrumentations for this experiment, okay, we use single cylinder 4-stroke engine, okay, with its characteristics, okay, and in order to measure the fuel consumption, we use Onosoki FZ 2100, okay. To test the performance of the system, we use asynchronous dynamometer, which is Kun Dyno, and then we use auto check to measure the emissions that emits from the engines. Okay, so this is the experimental setup. Okay, the experiment have been carried to the 4-stroke 125cc carbureted engine. Okay, and then the experiment have been operated at wide open throttle with different variable load. Okay, this experiment have been tested for engine performance, fuel consumption, and exhaust emissions. Okay, this is the photos of fuel injection system, port fuel injection system. Okay, as we can see the photo at the right side, that is the retrofit fuel injection system that will replace the carburetor system on the conventional motorcycles. So for the experiment setups, there are two setups. First setup is to investigate and determine the optimum intake manifold angle and fuel injector location. Okay, and then the second setup is to compare the performance between PFI system and the carburetor system. Effect of intake manifold angle and influence of fuel injector location. Okay, so we studied for the brake power, BMEP, and fuel consumption. Okay, as we can see, PFI 150 degree intake manifold and 68 degree for the injector location have produced highest brake power, and then consume low fuel consumption and produce high brake mean effective pressure. While for the emissions, okay, as we can see, PFI 150-68 okay, emits low CO concentration and CO2 concentration. However, it penalizes the higher hydrocarbon concentration. Okay, so for the summary, obviously a 90 degree angle of intake manifold are not an optimum parameter. Okay, the acceptable results that have been produced is PF 150-48 and PFI 150-68. Okay, based on these two angles, we choose PFI 150-68 for the optimum prototype because it produces high brake power, high BMEP, low BSFC, and emits low CO and CO2 concentrations. Okay, The second setup is to compare the performance between port fuel injection system and the carburetor system. Okay. So as we can see from the results, okay, the produced retrofit port fuel injection system, okay, give highest work power as compared to the carburetor system, okay. And however, it still consume more fuel consumption as compared to the carburetor system, and then it produce high BMEP as compared to the carburetor system. Okay, and then for the emission concentration, as we can see, for the CO and CO2 concentration, there are significant decrease for PFI system. Okay, however, on the hydrocarbon concentration, the carburetor system is much lower. Okay, hydrocarbon is higher for PFI system due to the mass of fuel injected, as can be seen in the BSFC result previously. Okay, so the summary for the comparative performance between PFI and carburetor system. Okay, PFI system has shown some interesting facts. Okay, which just produce high brake power. Okay, with 94% power gain. Okay, high BMEP with lower CO and CO2 emission. However, it penalized by high brake specific fuel consumption and high hydrocarbon emissions. Okay, so for the conclusion for this project, retrofit fuel injection system kit has been developed. Okay, performance and emission characteristics have been experimentally investigated and simulated. Okay, engine performance and exhaust emission influenced by intake manifold angle and fuel injector location. Optimum intake manifold angle for this project is 150 degree. Okay, while for the fuel injector location at 68 degree has reduced CO and CO2 concentration effectively. Okay, so based on 4 different intake manifold, PFI 150 degree over 68 degree is the best intake prototype for PFI system. Okay, so the contributions to the knowledge for this project, retrofitting small gasoline engine through novel PFI system, okay, will provide improved performance. Okay, for the GT power simulation study, the developer model has been able to predict the performance of a retrofitted engine. Okay, intake manifold angle has significant influence to the engine performance. High angle will produce better performance and reduce emissions. Retrofitting approach provide beneficial solution because it uses low capital investment with minor modification. Okay, this project has potential markets. Okay, it can be used for individual small engine users, and also it can be used for the companies that use small carburetor engine extensively, which is Post Malaysia, Pizza Hut, and so on. Okay, thank you. If you have any question, okay, can kindly contact me. Thank you very much.